Hi, AP Stats. As promised, we're going to just really quick finish this example and talk through the independence of each of these. So for the first one, it says A is a red card, B is a club. In order to decide whether or not these events are independent, we need to check either the probability of A given B and whether or not that's equal to just the probability of A, or of course we could do this, the probability of B given A versus the probability of B. So if I'm considering the probability of B given A, that's the probability that I select a red card given the fact that I know the card is a club. The probability that the card is red given the fact that I know it is a club. Well, if I know that the card is a club, I know it is a card that is black. I know it is not a red card. So the probability that it is red, given that I know it's a club, is 0. There's no chance of it being a red card if I know it's a club. Well, then let's compare that to the probability of A, which is the probability of being a red card. Well, there's half of the cards in the deck are red, and so obviously these are not the same. 0 is not the same as 1/2. These are not equal to one another. These two events are not independent. Meaning knowing information about one does tell us more about the other. Then if we look over at example 3, our events are red and heart. So again, we're going to compare whatever probabilities we want, really. So let's say we compare the probability of A given B. We want to see, is this equal to just the probability of A? Well, the probability of A given B, the probability that this card is red, given the fact that I know it is a heart, well, if I know it's a heart, I know it's a red card. So the chances that it's red, given that I know it's a heart, that's 100%. And then if we compare that to the probability of just being a red card, well, that's 1/2. We already knew this, right? And 1/2 is not equal to 1, and so this means that these two events are not independent. Sorry, my pen is not really working very good right now, but those are our solutions. And the only thing I want to point out is looking at these answers, we have an event that's mutually exclusive but not independent. We have an event that's not mutually exclusive but independent. And then we have an example of not mutually exclusive and not independent. This is most likely the 3 that will happen. It is very unlikely that 2 events will both be independent and mutually exclusive. It is unlikely. Oh gosh, hold on one second. It is unlikely that 2 events will be both independent and mutually exclusive. Oh my goodness, exclusive. This is because in order for this to happen, the probability of one of the events would have to be 0, and realistically, we're not going to look at any events that have no likelihood of happening. If you want me to do like a proof, I guess, of this statement, let me know. That would be maybe more of an individual thing, but I'm not going to do it for the whole class because it's not super, super important. All right, that is all I got for you right now. I hope you have a lovely weekend.